Good morning, 6th grade. So, I am standing here in my kitchen of my house, just quickly going to go through a couple things that you need to do since you were not able to physically do this lab on your own. So, let me start off by saying that there is really no replacement for doing the labs yourself, but I'm going to do my best to kind of supplement. So, first thing that it asked you to do was to gather your materials. One thing that I've already done is I have a pot on my stove with some water in it. It's filled about 3/4 of the way up, and I put it on the heating element, which just caused it to boil. As you can see, all this steam is rising off of it in evaporation. I also gathered 3 different materials for different spoons and stuff that were made out of different things. I grabbed this that is completely metal all the way up. I grabbed this ladle spoon thing that is plastic. And I grabbed a wooden stirring thing. Yeah, I know, laugh it up. It's fine. Spatula. Spatula, whatever we want to call it today. It's a stick. Okay, so what we're going to be doing is we're going to be putting them in that pot and measuring what happens to them over an expended period of time. So for right now, take a moment and fill in the pre-lab questions for what the 3 items that you're using are: wooden spatula, plastic spoon, metal scooping thing. Then take a moment and fill out what you think the independent and dependent variables are. Remember, independent is something that I, as the researcher, am changing, and dependent variables change because of what I changed. After you're done with that, I want you to take a hypothesis of what you think is going to happen. Make sure you put it in an if-then statement. If I put metal, wood, and plastic in a boiling pot of water, then explain what you think is going to happen. I think that the plastic is going to heat up the fastest. I think the metal is going to heat up the slowest. I think that blah, blah, blah. Whatever you think is going to happen. Now, what I'm going to do is I'm going to set a timer on my phone. On the timer, I'm going to set it to go off every 10 seconds or so that I check it at the correct intervals. I'm going to quickly talk to you guys about what is happening during each one of these. So turn off my heat, put each one in, 1, 2, 3, and I'm going to set my timer. Now, as I explain what they are, I want you guys to put these into the box. I took note of how they felt beforehand, and I'm going to take note of how I feel them each after. So the first one, no change in the plastic. No change in the wood. Slightly warmer with the metal. Three, 2, 1. Wood, no change. Plastic, no change. Metal, warm. 10. Okay. Wood, no change. Plastic, no change. Metal, definitely warmer. 5, 4, 3, 2, 1. No change in the wood. No change in the plastic. Metal is significantly warmer, almost too warm to touch. And 3, 2, 1. Wood, warm. Plastic, no change. Metal, hot. Don't want to touch it. So, now that you have a little bit of the data, what I want you to do is I want you to take a moment and answer the end conclusion questions. Was your hypothesis correct? Yes or no? How were the materials affected by placing them in the hot water? Were they different from one another, or were they the same? Talk about conduction, how objects need to be touching for conduction to occur. What was touching what in this? And I'm not just talking about my hands touching the spoons. Talk about what might be good conductors, allowed it to move easily throughout the material, and what might have been good insulators, which caused the heat to move slowly up it. And really, I want you to take a moment, and I want you to think about why we use certain materials when we are cooking. Why is it that most of the kitchen materials have some sort of plastic end or wooden end? Like, I went to go grab this a little bit earlier because it was metal, but then the end of it was wood. Take a moment to think about that. I'd like to hear what you say in the conclusion section. Thank you.